Up to lesson 5 in the week, although it says lesson 6 on screen, ignore that, it's lesson 5. We're actually multiplying decimals this time by powers of 10. Last week we multiplied whole numbers by powers of 10. This week it's decimals. So a little bit of a revision. Here's some questions that I want you to think about. How does the value of a number change when you multiply it by 10? Think about that for the moment. Say if it was 6 times 10, how does that change when you multiply it? The value of the number increases 10 times, so 6 becomes 10 times bigger, 60. It also moves up one place value. How do the place values of the numbers change? Well, I think I might have just answered that. How do the place values change when you multiply by 10? It should change one place to the left, so tenths are renamed ones when multiplied by 10. What would the number change if you multiplied it by 100? Alright, so if we multiplied by 100, it should change 2 places and move 2 places to the left. And how does multiplying whole numbers by powers of 10 compare when multiplying decimals? Okay, so the question is, if we multiply a whole number by a power of 10, is that any different really to multiplying a decimal by a power of 10? And the answer is no, they're pretty much the same process. We do exactly the same thing, and we'll see that as we go through this lesson. All right, so I'm going to use the number slider again just to give you a reminder, but this time we're involving decimals. So we're going to use the number slider to find the number 1,000 times bigger than 62 8/10. So I'll pull up the number slider, and there you go, I've got it already. So there's 62 8/10, and I'm going to multiply it by 1,000. So the difference here is we're now involving decimals. So if we're multiplying by 1,000, we've found it's going to get larger, and by 1, 2, 3 places. So let's apply. I'm predicting the 6 is going to end up over here in the tens of thousands. And there we have it, 62,800. So we're also asked to predict what's going to happen to 428 7/10. So I'm going to enter that in. And we're asked to multiply it by 10. So I'll update my slider. There's my number now. I multiply it by 10. Again, the digits should move one place to the left. So I'll apply that. And there we go, we are correct. If I update my slider again, it will go back to my number that I started with. Multiplying it by 100, what do you think is going to happen? You should have just told me that it would move 2 places. So the 4 will move up 2 places, as will the 2, as will the 8, as will the 7. Notice that 4, 2, 8 and 7 are all side by side. If I do the opposite, divide by 100, they're all still beside each other. 4, 2, 8, 7. That's still the same order. It hasn't changed. All right, now we're going to multiply by 1,000, and it should be 3 places it all moves. So it does do exactly the same thing when we are multiplying. So let's see, this should have been what we found. When we multiplied 62 8/10 by 1,000, 62,800. And when we multiplied 428 7/10 by 10, then 100 by 1,000, we came up with those results there. All right, here's one for you. So I would like you to pause the video in a moment and then have a go at each of these. So it's easy to set out this across those lines. Pause the video and see if you can come up with the right answers. Do that now. Welcome back. I hope you did that confidently. Now let's check your answers. First of all, let's see what happens when we multiply 36 9/10. The 3, the 6 and the 9, they're all still there. We can see those digits in all three of these sums. They are still side by side. Nothing's gone in between them, but they have moved larger. That was hundreds. Now it's thousands. Now it's tens of thousands. And when we multiply 61 and 24 hundredths, two numbers here follow the decimal point, but when we multiply it by 10, only one number. To get rid of any numbers following the decimal point, we multiplied it by 100, and then we multiplied by 1,000. Again, it's moved a place value larger. Here we had one number following a decimal, two numbers following a decimal, three numbers following a decimal. So I'm predicting when I multiply 9 and 403 thousandths by 10, two numbers are going to be following the decimal point, 94 and 3 hundredths. Let's see if I'm right. 94 and 3 hundredths indeed. Multiplied by 100, multiplied by 1,000. And again, I'm going to reinforce that certain numbers don't change. All right, time for you to have another go. Have a look at these ones. These ones are written horizontally this time. See if you can work each of these ones out. Pause the video and do that now. All right, let's see. 12 and 45 hundredths moves two decimal places larger. The decimal's gone because it's had to move two places. I wonder if the same is going to happen with the next one. 8,034. The same digits, 8034, 8034. Decimal point moved this way, or the numbers actually moved to the left. All right, multiplying by 10 should move it one place, so I'm predicting 62 and 8 tenths. And in the last, it should move two places, 974 and 1 tenth. And there you go. All right. Now, this one's a little bit different, so it's applying your understanding a little bit differently. This time we have to identify whether it's been multiplied by 10, 100, or 1,000, or something else. Now, it has got larger each time, so you need to work out how many places it's moved. 9008, 9008, so they're still there. The decimal point was here. It's now here. It was here, so it's gone 1, 2, 3 places. What do you predict? Pause the video and have a go at each of these. Well, I hope you're working confidently, so let's see what the first one says. Did you predict it's by 1,000? Indeed it is. It has moved 3 places. The decimal point in 16 hundredths is before the 1. When there's no decimal point shown, we assume it's after the last digit, as it is indeed. So to move it those 2 places, it had to be by 100. To go from 72 and 4 tenths to 720 or 7,240, it's multiplied by 100. And in the last one, it was multiplied by 10. So I'm going to remind you, the digits remain the same. They are in the same order, and they remain the same number of places apart. So the digits remain the same, 102, 102, 102, 68, 68, 68. Nothing between them. The 6 is beside the 8, the 6 is beside the 8. So they're in the same order and in the same number of places apart. Now here, you're actually applying your understanding a little bit further, and you're applying it to see if you can work out a number sequence. It's no different really, because to go from 1 and 2 hundredths to 10 and 2 tenths, the digits are the same, so we've multiplied it by a power of 10. So indeed, it has moved one place larger. The 1 here is in the ones. That's the ones place there. It's gone up one place value. Again, gone up one place value. So continue the pattern by going up one place value for A. See if it's the same for B and C. Have a go, pause the video and see how you go with this different understanding of powers of 10. All right, do so now. All right, let's see how well you've applied your understanding. All right, so the 1, the 0 and the 2 are in the same order. They are the same digits and they are the same number of place values apart. The 1 is followed by the 0 is followed by the 2. However, to move it one place value larger, we had to have another 0 holding that place. 1020 and then 10,200. How did you go? I hope you did well. If you didn't go well on that one, have another look at the pattern before you check the next answer. So if you need to, you can pause the video. Otherwise, let's just march on. As you can see, the 6 was 3 places from the decimal, then 2 places, then beside the decimal. Now it's jumped over into the ones and the 7 has followed. So 6 and 7/10 and 67 are the two answers you required. And in the last one here, it keeps getting a place value larger each time. I hope you did those with confidence. All right, the next lot of applying is to problem situations. Now this one's a little bit different. You're not actually solving the problem here. You're just coming up with a number sentence, and the first one's actually done for you. So I've got 98 cents multiplied by 10 and turned that into a story. Jamie purchased 10 apples at 98 cents per apple. How much did Jamie pay altogether for the apples? Don't have to answer it. Just see if you can come up with a number sentence to suit and a question. So notice it's in two parts. It's got the information and then it's got a question to follow. So see if you can do it in two parts. See what you can come up with there. If you struggle, play the first part of the video, see what the first one says, pause it and then come back to it. Okay, away you go. Pause the video and have a go at these ones. Now that was probably a bit of effort, especially coming up with a suitable story. $56.04 is an unusual amount, but I wonder what you might pay that much for. And then 100, that's how many times you would have done that. Let's see. I've shown you all the answers at once, but anyway, not to worry. This example says 100 people each paid $56.04 to hire a DJ for a party. That's the information which contains those two figures, requiring them to be multiplied. How much did the DJ get paid is the question posed to answer that. And if you happen to come up with an answer, I think you might have said $5,604. Okay, and then 58 cents multiplied by 1,000. So in this example, the shop owner ordered 1,000 stamps, and at 58 cents each, how much did the shop owner pay for all the stamps? All right, again, you didn't have to answer it, but if you think moving a 3 place value is larger, 1, 2, 3, you'd have come up with $580 if you decided to answer it. All right, how did you go today? All right, some little jokes here to finish off. These ones are a bit better, I think. I like these, especially the last one's my favourite. What did the big flower say to the little flower? Hi, bud. What do you get? Or why did the pony get sent to his room? He wouldn't stop horsing around. I wonder if you've been sent to your room over these holidays or over this time. Okay, hopefully not. What do you call a bear with no ears? Here's a clue. B. Why wouldn't the shrimp share his treasure? Because he was a little shellfish. Uh, what did the fisherman say to the magician? I know some of you like your magic tricks. Pick a cod, any cod. And here's my favourite. I actually did laugh at this one. What do you call a cheese that's not yours? Nacho cheese. Oh, Terrible, isn't it? I did like that one though. All right, guys. Hope they were a bit better quality than yesterday's ones. Take care again and catch you for tomorrow's maths. All right. See ya.